All right, hello everyone. So today we have a discrete math problem. Solve the congruence equation 19x is congruent to 3 mod 101. So I'm going to be using this theorem to solve this congruence because this theorem guarantees a solution for us. Okay, and the theorem says if you have ax is congruent to b mod n, where the GCD of a and n is 1, then a solution exists. X is congruent to a bar b mod n. Okay, and a bar is an integer, where a bar is such that a bar a is congruent to 1 mod n. Okay, and that's what a bar is the inverse of a modulo n. Okay, now there are other conditions where there might be a solution to a congruence equation. However, this is like a prescribed method and it guarantees a solution. If the GCD of a and n here is not equal to 1, 2, 3, 4, it's possible that your congruence would have a solution, but it's possible it does not. Okay, and we don't really have a prescribed method for that. Now, in our case, let me just identify a couple things. My 101 is my n, my 3 is my b, and my a is my 19. So just aware of that. And if I want to use this theorem, the first thing you have to check is that the GCD of a, the 19, and the n 101 is equal to 1, which it is. Right? The only divisor that goes into both is 1. They're both prime, so that's going to occur. The next thing is, in my opinion, the most computational involved part of these problems, which is finding a bar. And a bar satisfies that 19 a bar is congruent to 1 mod 1. And the way you find a bar is by using the Euclidean algorithm, or you can do this by inspection as well. Inspection, though, only works out kind of nicely if you have easy numbers to work with. So for example, if you had, and usually small numbers here. So if I had, just for as an example, 3 a bar is congruent to 1 mod 7 here, then a would be a bar equals minus 2 would work, because 3 times minus 2 is congruent to 1 mod 7, because 3 times minus 2 minus 6 minus 1 is negative 7, and 7 does divide negative 7. So that's what I'm trying to get at, is that's how you can do it by inspection. However, it doesn't quite happen that easily with rather large numbers like we're working with here. So you would have to use something like the Euclidean algorithm. Now I'm not gonna go over the Euclidean algorithm. We can do a separate video on that. But in this case, your a bar would come out to be 16. Okay, and your solution here, getting the actual solution is not that bad. It's just plugging in your a bar and multiplying it by b. So a bar was 16, b was 3 mod 101, so you get 48 mod 101, and yeah, that is your solution. And just to be aware, sometimes your solution that you get, the a bar b part is greater than your n, so if that's the case, you can always divide by the n, and then so if my answer was 150, technically that's fine for my a bar b. If you divide this by 101, whatever that remainder is, that would be a solution. So just be aware of that, because often, most books, and understandably so, this number will always be less than whatever n is, okay? So just be aware of that. And there you go, that would be your solution. So once again, this is a method to solve a congruence equation where the GCD of a and n in the equation is equal to 1. If it's not equal to 1, then as I said, we don't really have a prescribed method, and it's more like a guess and check kind of thing. Okay, I hope this helps. Thank you for your time.